Now we're going to focus on properties and changes of matter. So, definition of physical properties. They can be observed without changing the chemical makeup of the substance. For example, the boiling point of water is 100 degrees Celsius. You can boil water, and during this process of boiling the water, it's still water. You're not changing the substance. Hardness, texture, phase, magnetism, conductivity, and viscosity are all other examples of physical properties that you can observe without changing the makeup of the substance. Viscosity, we're going to focus on that definition for a moment. It's the resistance to flow in liquids and gases. A highly viscous substance is thick, slow, and dense, and a low viscous substance is thin, fast, and not dense. So to decrease viscosity, you just heat up a substance or increase the temperature of it. So here's a demonstration of viscosity. We have 4 different test tubes, and they each have a different thickness of motor oil in them. Each of them has a marble at the bottom of the test tube. So I'm going to invert them. And now we can see the marbles are falling, but they are falling at different rates. So you'll notice the one in number 1 appears to be falling the fastest. That means that the liquid is the thinnest or the least thick of all 4 of these, and therefore it has the lowest viscosity. So least thickness, least viscosity. As opposed to number 2, you see the marble is still up here and it's very slowly moving down through the motor oil. So this has the highest thickness, which equals the highest viscosity. So thickness equals viscosity. Low thickness, low viscosity. High thickness, high viscosity. So if we look at the picture here, this one is going to be high thickness. So it's going to be the highest viscosity. Whereas this one over here looks like it's flowing the fastest, and so it's going to be a low thickness, so a low viscosity. Now we're going to focus on whether or not a physical property is extensive or intensive. So extensive means it's going to depend on the amount of matter that's present, and it's going to become different if you change the amount of matter, such as mass, length, volume, or total energy. An intensive property does not depend on the amount of matter present, so if you change the amount of matter, this property would remain the same, such as melting point, boiling point, density, ductility, malleability, and color. Here are some examples. First, this is a piece of graphite. And you'll notice that before I change the amount of matter or cut it in half, it's got more mass. But if I were to then cut it in half, then it would have less mass after I changed the amount of matter. So because these became different, this is an extensive property. Mass will change if you change the amount of matter, so it's an extensive property. The length before is this long. And if I were to change the amount of matter or cut the amount I have in half, then the length would become shorter. So because these become different when I change the amount of matter I'm dealing with, this length is an extensive property. Volume is the amount of space an object takes up. And I'll actually use the wax as an example. So if the wax has this volume, takes up this space, but if I were to cut the wax in half, then I would take up half as much space. So more space, less space, because it becomes different when I change the amount of matter. Volume is an extensive property. Going back to the graphite, I looked up the density of graphite, and here it's 2.26 grams per cubic centimeter. So if I change the amount of mass, I am simultaneously changing the amount of volume. So this piece has half as much mass, but it also has half as much volume. So because the mass and the volume are in proportion with each other, the density still is 2.26 grams per cubic centimeter, even if I have half as much. Because the density is the same before and after I cut it in half, that means density is an intensive property. Okay, let's take the wax again, for example. Here is before, and the color of it is, besides it being a little bit dirty, is basically kind of a white color. And then if I were to cut it in half, does the color change? No, it still has the same color. So since the color is the same even after I cut it in half, then color is an intensive property. The melting point of graphite is about 3,600 degrees Celsius. So if I were to put this on heat or on fire and try to melt it, it would have to be this temperature in order for it to begin to melt. If I were to cut it in half, it would still take 3,600 degrees to get this to start melting. So because the melting point is the same, whether or not I have half as much matter means that melting point is an intensive property. Finally, conductivity is the ability to conduct electricity. So wax does not conduct electricity. And if I cut it in half, then it still does not conduct electricity. So since it's still the same, the conductivity before and after cutting it in half, that means conductivity is an intensive property. Now it's your turn to try and categorize several properties as either intensive or extensive. So right now, you should pause the video, get out a sheet of notebook paper or use your mind, and label each of these properties as intensive or extensive, and then when you unpause the video, I will go over the answers. So now let's look at the answers to each of these. Mass is going to be extensive. If I change the amount of matter, it's going to change the mass. Color, intensive. Color will not change if I have half as much. Ductility is the ability to draw a metal into a wire. And so the ability to make something a wire is not going to change if I have half as much. I can still make it into a wire, just a smaller wire. Boiling point is going to be intensive. It doesn't matter how much I have, the boiling temperature is still going to be the same. Density is intensive. No matter how much of the mass you have, you also have an equivalent volume depending on its original density, and so that won't change. It'll stay the same. Heat energy is extensive. The more particles you have, the more heat energy that's present. Luster is going to be intensive. It'll be the same whether you have a whole lot of shiny metal or half as much of the shiny metal. Melting point, intensive. That's not going to change depending on how much you have. Length is extensive, volume extensive, and weight extensive. All of them are going to change and be different if you have half as much of your material. And then finally, malleability is the ability to hammer a metal into a flat sheet. And so that's going to be intensive. It doesn't matter how much of the metal you have, your ability to hammer it into a flat sheet is going to remain the same. Lastly, there's going to be a Canvas question where you should submit the answer to this question. Why is viscosity intensive? And illustrate an example.